Hello, everyone. Welcome to today's show. And if you are joining for the first time of our digital transformation series, for which we meet every Thursday at 5:30 p.m. Eastern, and we pick one topic related to digital transformation, and we always have a very exciting panel for you. For today, we are going to be picking the topic called shop floor information architecture. We are going to be living our life inside the shop floor, and we are going to be talking about different systems, different user personas, how they are going to be interfacing with the systems, and how these systems are going to be talking to the enterprise layer. We are also going to be talking about different challenges when we think of different company sizes, and different industries, how their needs are going to be different as far as the shop floor goes. So before we do that, we are going to ask everybody to introduce themselves. So Tom, I'm actually going to start with you. Would you mind introducing yourself?
Not at all, Sam. Thanks very much. My name is Tom Rodden. I am the CIO at Herron Medical Systems. And this is an exciting topic for me because I am not only an IT professional now, but in a former life, when I worked for GE, I spent about 10 years running the supply chain in one of the GE business units. So this is very near and dear to my heart in multiple ways, systems and supply chain. So great to be here.
And Tom, you are going to enjoy this panel. I'm telling you, this is the most powerful panel that we have had so far. You are absolutely going to love it. Okay, so I'm actually going to move to Mark next. Mark, would you mind introducing yourself, if you don't mind?
Sure. My name is Mark Lilly. I'm president and CEO of Lilly Works. I'm very excited to be on the panel today. We help manufacturers solve the late problem, specifically with and by improving their production management capabilities and visibility on the shop floor. So for that reason, very excited about today's conversation.
Okay, amazing. Thank you so much for being here, Mark, for the first time. We are super excited as well to have you. Dave Crysler, can I move to you next for your introduction?
Sure. Hey, everybody. My name is Dave Crysler, and I own a company called the Crysler Club. We are operations consultants working with manufacturing, construction, and cannabis owners to help them create systems to reclaim their life and grow their business. And I come to you with more than 20 years in manufacturing, directly working on the shop floor and throughout leadership, implementing ERP systems. Thanks for having me, Sam.
Okay, amazing. Thank you so much for being here, Dave. Now, Dave Griffith, I think we are going to have a little challenge here with names. So Dave Griffith, would you mind introducing yourself next?
No, absolutely. Thank you, Sam. Hey, everyone. My name is Dave Griffith. I run a company called Kaplan Solutions. We help manufacturing companies go through digital transformation processes that pay for themselves. And so with us, much of that is working with operators and people directly on the shop floor, connecting them to all the other systems that we're going to talk about later today, and then finding ways to make decisions with the data we've been able to capture. Thank you for having me, Sam.
And Dave, you know what I'm looking for today. I am looking for the debate to get a little intense, especially we have IT and OT together in the same room. So hopefully you guys can deliver on that. Thank you so much for being here. Jennifer, can I ask you to introduce yourself next?
Yeah, hi everybody. My name is Jennifer Herron. I'm CEO and founder of Action Engineering, and we empower model-based visionaries to use digital data in the design, manufacturing, and inspection space. And we're really intensely focused on how we get folks to adopt discrete manufacturing tools like CAD and digital design solutions, CAM solutions, digital metrology solutions, and digital twin technologies. And we have lots of experience working with small companies, medium, large companies, and connecting the silos of design, manufacturing, and inspection, which we know are typically quite isolated from one another. And we would really like them to all work together so that the products are better and of higher quality.
Yeah, and this is going to be even more fun because now we have IT, OT, and engineering as well in the same room. Can you believe this? Okay, this is going to be so much fun, guys. All right, so I am actually going to start with Tom first, and my goal, to sort of setting up the stage is going to be if you can talk about a specific story, and that is going to be a specific, business or business model, and if you can describe the kind of, products you were building as part of that business, and what was their business model like, and then finally describe the system and architecture as far as the shop floor goes. So do you want to share your story, Tom?
Sure, I can try and do that briefly here, Sam. So I'll use the example of the company I've been at for the last 14 years, Herron Medical Systems. I've not only been the IT leader of the application space before becoming CIO, but also we did implement not only an ERP, but an MES shop floor system and a constellation, small constellation of other systems. So I hope I can describe the architecture and that collection of systems for you. Our overall mission at Herron is to fight cancer. We produce radiation therapy equipment, which are basically very large machines, the size of a CAT scanner or an MRI machine. But these are not for diagnostics. These are for treatment. So the machine generates a laser beam and then fires that into human bodies to kill the cancer cells in tumors. So this is one of the three forms of cancer treatment between surgery, chemo, and radiation. So these are very expensive machines and multi-million-dollar machines that we produce. And we have a number of factories around the world, but they're all following fundamentally the same process. So we start with the ERP. System number one in the architecture, and that's where we are generating our production orders from MRP runs. And from there, we use an MES system. It happens to be SAP, but it could be something else. We have an interface between the SAP ERP and the SAP MES system. They call it ME. So that's the second system in this architecture. And there is a copy of the ERP production order brought into the MES system. That interface is through a third piece of the architecture called MII in SAP's parlance. So now we have three parts to the architecture. And that is a critical integration and also dashboarding tool for reporting and monitoring of the performance of the MES system and of machines that we'll get to in a minute. So we now have three parts to the architecture. And we'll go through the MES flow where parts are staged, and that's all still in the ERP system really, but as they're consumed on a production line where we're making the machines and a backflushing process takes place to consume the components, we get to a point where we have produced an assembly. And again, these are large machines, so there's many stations along the way producing assemblies that will ultimately be assembled into the final product. The vendor parts are serialized in many cases, not maybe all. We don't have serialized screws, but any significant parts are serialized by the vendors. As we build our assemblies, we are serializing them. So at the point at which we produce an assembly and receive it into inventory and consume the components that went into it, that triggers a fourth system in our architecture, a barcoding tool. And I think we use a tool, a software product called Loftware, but there are many out there.
Yeah.
In any case, that's yet another part of the architecture. We're serializing the components. We'll build it into a final assembly. There's also, throughout this process, a scanning of the components as they are brought to the line, a scanning of the subassembly to receive it back into inventory. So this is a fifth element to our architecture, another barcode scanning tool. We then have a process also. I guess it's not really sequential here. It's all happening more or less simultaneously. But as we are making use of the parts, we are also employing tools that are carefully calibrated, and we must scan the tools as well in order to ensure that we are using legitimately certifiable calibrated tools. And that is all recorded, the parts, the user, the calibrated tool in the device history record that we're generating without any paper throughout this process. That will ultimately enable us to present a robust final device history record to the FDA or anyone who might be looking for evidence that we've followed our processes and that the device is of high quality through a quality process. But the amazing thing, I didn't even know this until I checked with one of my team yesterday, but there was also another integration, a sixth part to our solution, which is something called plant connectivity, or PICO, a piece of software that connects the MES system to the devices themselves. For example, telling the device the amount of torque that should be applied when screwing the bolts. And this element is, a sixth piece of the architecture, and that enables us, again, that'll all be recorded in the device history record. I think those smart tools and the integration of that there's several different smart tools. That was just one, sort of the bolt tightening device, but those are the fundamental parts of the architecture for us. So I hope I haven't taken too much time, Sam, but I just wanted to lay that out for people so they have kind of a case and see where these fit in.
So, by the way, this is great description, amazing context in terms of the story, absolutely love it. But when the OT folks are trying to listen to this episode, obviously they are interested in everything, but they are, primarily interested in number 6. Okay. For them, number 6 is going to be OT. Everything else is going to be IT. Did you have any other components in the OT side? And I am actually looking for some more details overall how your networks were structured, because OT is going to have very different network in terms of the connectivity, how OT and IT networks are going to be, whether they share the same network, different network, because you are in the medical device business. Now, this is a serious business from the cybersecurity perspective. So I'm pretty sure you guys have thought this out, right? So I don't know if your networks were isolated, same from the OT and IT perspective, Tom. Do you have any more colors there by any chance?
The networks are not isolated.
Okay.
It's the same network. I did miss one. I just looked at my notes. I did miss one further, maybe IT tool, as you call it, Sam, but the work instructions. So
okay.
The work instructions are actually stored on yet another system, which is kind of very secure. And these are PDFs, so not easily changeable, gone through a document approval process. So we're using a document management server and solution. And those are called real time into a view within the MES as people are proceeding through the manufacturing process. So that's the 7th piece of the architecture that I left out in my initial description.
Okay, love it. Thank you so much, Tom. So I'm actually going to move to Mark. So Mark, do you have your story ready in terms of the architecture, the business model?
Sure. Thanks, Sam. Typically, our clients and the type of manufacturing companies I deal with are much smaller in scale than I think Tom's enterprise, certainly. I mean, we're talking about 5 to 50 million, maybe 100 million in size. Many don't have an ERP, or even if they do have an ERP, they're running production off of spreadsheets. So the architecture is really, certainly they have machines, whether they're CNC machines or, your mills and your lathes and whatnot. Maybe some have robotics. Certainly most have an internal network that maybe those machines are tied into, maybe they're not. Some do machine monitoring, right, for overall equipment efficiency measurements, things like that. But in general, and I think my main point in terms of the architecture would be in spite of a lot of nice technology that's out there, what we find is a lot of companies still struggle with getting their products out on time. So I'm sure Tom and a company his size has nailed this. But companies of the size that we typically deal with, they struggle with simple things like where's the work order, right? How is it progressing? In any work center, what do I work on next? And even those who have an MES system, for example, what are the priorities that are being fed into the MES, right? What are the signals there? Is material part of the equation? It's nice to understand your priorities, but do I have the material here to actually execute on these priorities? And if not, when might I have that? So it's, what we find is a lot of the struggle of dealing with these simple questions. Where is the work order? How is it progressing? What do I do next? And then you get into the future looking, right? And so every salesperson is bugging production. When is my customer going to be able to get their order, right? So now you're looking into future, and you're looking at evaluating capacity and all the hundreds, maybe thousands of other jobs and work orders you have in production, and how can you actually come up with an answer that your salesperson, let alone your customer, is going to believe, right? So.
Okay, amazing. So thank you so much for the story and the description. And my, understanding here would be based on the description that you provided, that, whatever Tom is doing, obviously, we are going to have those 6 or 7 components. In addition to that, in your architecture, you are probably going to have one more component, which is going to actually decide the priority of the work order, because the core ERP system or the MRP system, obviously they are not as good at the priority. We all know that, right? When meeting the real world needs. So do you want to paint a little bit more colors into, if you have seen more systems in the architecture, or, is this the extent of it that, they can live simply with either the ERP system, ERP plus prioritization system, plus MES system, plus I don't know what else.
Right. Yeah, exactly. It's a real mishmash. And I guess my point would be is regardless of the fact that they may have a very high end ERP, they may have machine monitoring, they may have, all sorts of CAM and engineering tools. Many clients still struggle with this idea of being able to answer these questions, of being able to get their products out on time. One of the simple things we find is the manufacturing in North America is very much make to order. It's custom. It's high mix, low volume, right? Not all. Most of the repetitive stuff has gone overseas. So what you find in that is the systems, especially the scheduling tools, whether embedded in an ERP or outside as bolt-ons today, they use a priority method essentially based on a due date. Well, the problem with that is in a high mix environment, you're going to have work orders that are due, say, 2 months from now, that are much more in danger of being late if you don't get started on it today than a work order that may be due just a week or two from now, right? Based upon how many operations it needs to go through. Does it have to go outside services and back 2 or 3 times, and so on and so forth? So by prioritizing things on due date, you're looking at and you're working on things that are due sooner at the expense of those jobs or work orders that are due much later. This is why I believe we see a lot of companies, again, regardless of the number of systems that they have, that are kind of caught in that constant catch-up mode. They're always trying to catch up. If you have an expediter, some companies have multiple expediters, especially at the end of the month. That's a really strong symptom of this type of effect.
Okay, amazing. Thank you so much, Mark, for that amazing insights there. And Jennifer, you are going to hate me for this, but when we talk about the CAD system or any of the desktop tools, I don't necessarily care, how many tools you want to use, because that's not part of the enterprise transactions and the enterprise bus. That does not really impact the core operational process. For us, when we look at the enterprise architecture, we are really looking at the systems that are really impacting our core processes, that are actually impacting our order processing, that are disrupting our machines. Sure, maybe CAD tools, can do that as well, but for the most part, they are going to be slightly more siloed from the architecture, so we don't have as much impact on the architecture. So, Dave, Crysler, I'm actually going to move to you for your story. Have you seen similar number of systems, more because you have been on the shop floor a lot more than these guys? So have you seen more systems in the architecture or less?
Yeah, I would say, thanks, Sam. I would say overall, it has probably been less in the environments that I have had experience with. So, Tom, I appreciate you kind of going through and sharing, the architecture that you guys are currently working in. I'm sure that introduces a handful of challenges on your shop floor. Having been there, I'm pretty sure of that. So, the companies that I work with now and in both in my past, there's a lot of job shops. And so, typically in that environment, from an architecture standpoint, we're going to look to simplify as best as possible.
Yeah.
Mark, I think you did a really nice job of kind of laying out some of the challenges that those types of companies come across on a pretty frequent basis. And, you see that, or I've seen that kind of play out in the architecture. So what I mean by that is you may have a small, manufacturing facility that is somewhere in the $10 to $20 million a year range, that has a ERP system with an integrated scheduling module in there, with some integrated business intelligence in there. That's a lot of the background that I have with the systems that I've seen and come into contact with. And depending on the specific type of manufacturing business. So, Sam, I can share with you one of the print manufacturing companies that I've worked with in the past. I'll give you 2 different examples, both from the same industry. So one print manufacturing company had a ERP system that then kind of tacked on a lot of, I don't want to say a lot, but a couple of different bolt-on products to help with the scheduling side, the data collection side, as it relates back into ERP, because that was one of those facilities happened to be a standard costing facility. So we needed to capture that data out on the shop floor, which I know is your favorite. So I wanted to throw that in there. And the other one, and I should say that one also had a bolt-on system for the CAD/CAM, the engineering side of things, because that was a converting facility. So they also had to keep track of individual dies to do the converting process. So in that kind of entire system, what we had was you had the ERP, obviously on the top end of that, and then that connected to the CAD/CAM system from a kind of planning and resource standpoint. and then connected to both the scheduling and to the data collection side of that. And the other example that I'll give is kind of one that was fully integrated. This happened to be an ERP solution that was industry specific, or more industry specific than my first example. And in that case, this particular ERP had modules that addressed kind of all of those components that we just walked through. So, the accounting piece, the CRM piece, the production piece, which handled data collection, as well as the business intelligence piece. So that was kind of wrapped up all into one, and challenges in both. But from my perspective, being out on the shop floor, anytime I go into an environment, I'm looking for ways to streamline what we are already doing from a systems perspective. Because what I've found is a lot of times people will just grab that bolt on and try to make something work, when there could be an opportunity to kind of, instead of recreating something bad that we already have, might be the best opportunity to kind of recreate something new moving forward. So.
Okay, amazing description there for the story. So I am going to have just one follow-up question. What did you guys do for the asset maintenance? Was that handled as part of the ERP, or did you have a separate bolt-on add-on for that? How did plant managers manage the assets?
Yeah, it was. So asset tracking was done in the ERP. All of the maintenance associated with the assets were handled in a manual system outside. So in several of those facilities, it was not I would say is not a significant enough asset list to have a full-blown system to handle the maintenance aspect of it. And the asset was tracked just from the cost allocation side in the ERP.
Okay, amazing. Thank you so much, Dave Chrysler. And Dave Griffith, obviously, I'm going to move to you next. But before that, you came with a lot of hope that I am going to be hearing a lot of Industry 4.0 OT stuff. But where is that? This conversation has become really boring. Okay, so that's why we have you here. So, okay, talk to us. So obviously, from the OT side of things, the only thing matters here is probably going to be the PICO system, PICO or PICO, Tom mentioned. So describe to us, what is happening in the Industry 4.0 community, because there's a lot going on, and daily I am hearing one extra acronym or the system, and it could be very confusing how to create the architecture around Industry 4.0 in my experience. So describe the whole stack and what you have seen in your story, and where these companies are really lacking in the architecture as far as the Industry 4.0 maturity goes.
Well, I'm glad you asked me kind of that very easy question, Sam. So thank you for throwing that softball up. I would say kind of generally, as to what everyone has talked about already, less is more. So when we look at what an architecture looks like, when we look at number of systems and number of integrations, I think less is always more, and the less moving parts, the less kind of bolt-ons that we have, the better and better that we will become as a manufacturing community. So specifically within the Industry 4 solutions, we hear kind of a lot of people have many different opinions. The one thing that I feel like we can say is that there is no standard. And so that's kind of the baseline that I have when I go in and I talk to customers is, what does this Industry 4.0, or what does this digital transformation mean for you? Because for all of them, they're going to have a goal as to where they're going to want to get as with their company. And it's our goal as industry professionals to help lead them down the path and help them solve whatever their problem becomes. And then if I may, Sam, with an example. So I was working with a company. I spent a number of years working with them. They make fittings and flanges. And so as I go in, I was talking about an MES system. So MES is manufacturing execution systems. Basically kind of it's a series of data collections and visualizations to allow us to know what's happening on the manufacturing floor and if we're doing better or worse than expected. So we of course go in and have that conversation about MES, and then we walk out on the shop floor and absolutely nothing is connected. And that is how I go and find, many different customers is they want to do this. They want that silver bullet of Industry 4.0, but they have quite literally nothing connected. And so because they don't have anything connected, a lot of that is understanding where they are, kind of looking at those asset lists as we had discussed earlier, and then from that going and actually doing a lot of the physical networking. We don't kind of have to get into the nuts and bolts of networking on the OT side because we could spend the next 12 hours talking about that. But again, kind of going through the process and building up an architecture. And then once we've built up an architecture, how we connect to the PLCs and the HMIs to be able to pull the data into servers where those servers live. And then from that point, kind of going and redoing many of the basics, be it PLC code, because we have to upgrade PLCs, or maybe we've got to go and do better visualizations on the HMIs, the human machine interfaces. At this particular facility, and one of the reasons why I talk about kind of the importance of all the little things is one of the people I was working with, they were talking to an operator of a box furnace, right? It's quite literally a furnace that is a large box that, the slide goes down and they heats for whatever the heat treat cycle is. Well, one of their issues, one of their key pain points on the shop floor was that this operator had to press the same 10 or 12 buttons every single time in order to go run a batch. And so, you go through a relatively simple process of determining if there's a reason why we have to punch those 12 buttons. There almost never is a good reason why we have to press the same 12 buttons every time. So we basically took those 12 buttons, made it into one button, and then we were able to run 1 or 1.5 additional loads per shift because the operator wasn't sitting there hitting the buttons. And so that's just kind of one of the examples of talking to the operators on the shop floor, because they know the biggest issues that you are going to find, and they're going to be, if you can show them that you can make measurable difference in their lives and make their lives better, they are going to be your biggest advocates out of anyone at the facility. And so kind of from that point, we did the exact opposite of what Tom was talking about in his example, is we basically built from the ground up. So now we've got these machines networked, we're pulling data into the servers, we're building some SCADA, so supervisory control and data acquisition systems, which helps to visualize, the machines and the lines. And then we're going and building MES and building some data acquisition systems to be able to go and showcase what actually is happening in the facility. And then as part of that, there were barcode scanners. We did some serialization. To Mark's point, we absolutely did some scheduling, because that in many facilities I go to is a major issue. And I feel like Mark must have been listening into my conversations in the last week and a half, because like it hits so close to home with that. This facility was slightly different. They were actually made to stock, and that's one of their things. So they had huge amounts of stock everywhere. And so it was a made to stock as opposed to a made to order facility. But like just that one particular example of, we can now go and run an extra, 1 or 1.5 heat treat loads per day. We did the calculations, and it was worth something like an extra $1 million, because they didn't have to physically buy another machine, and because they didn't have to physically buy another, and they didn't have space for another machine. So it would be, we have to build a building, we have to build another machine. And so there are many different opportunities while looking at taking some of this technology and bringing out on the plant floor that are going to help, not only the bottom line of the businesses, but the moving and everything of the operators. And once we can get input from them, and once they have become our champions, we're now able to do much more of these, higher value initiatives, and implement many more of these other IT systems, and be able to do that much smoother.
Okay, first of all, great description of the story, great, journey about the user as well. By the way, I'm definitely interested in going a little bit more into details because, in my case, when I look at, if I'm positioning myself as the ERP, I get like two guys, okay? Yep. And if you look at the Industry 4.0, attention, okay, if you look at the Industry 4.0 community on Clubhouse, we have 7,000 people. Industry 4.0 Solutions has 2,000 people. So they must be doing something there, right? And here you are saying that, this is just one system, which is MES system. Tom mentioned that you have the MES is talking to Pico. So what is so involved in the architecture that IT people don't understand? Do you want to go a little, one level deeper? And what should be part of the enterprise bus when we are going to be connecting these systems as opposed to them being siloed. If an operator is simply utilizing a system, based on a machine that does not talk to anybody else, I'm okay, whatever you want to do there, I don't have any problem. But when it is going to talk to the main bus and that is going to be impacting the transactions, then I am probably going to have some issues. And I also have some issues with the network connectivity as well. How these networks are actually going to be talking to each other and who's going to be controlling the cybersecurity processes. So do you want to go a little deeper into the story by any chance?
Absolutely. So I would like to point out that the person, the IT person in this company, his name was Ralph. He was the best IT kind of compatriot I will probably ever have, because very early on we made the decision of, he handles all of the IT stuff. We handle all of the OT stuff. We are partners in this. We're going to work together in order to figure out whatever makes the most sense for the company. And so for me, the best goal is to have kind of a Ralph on the other side of every single one of these conversations, is to have a partner on the IT side who we speak the same language and we have the same end goal. And they know, this is what they're very good at. They're good at the networking. They're good at the IT side. Let us bring some OT networking experience in. Let us bring, kind of the OT experience in, and we'll work together in order to go ahead and figure out the best solution. So I would say the goal has to be to kind of turn those potentially negative conversations that we all hear about, especially on LinkedIn, from, the IT side of, we're nearly having fisticuffs with the IT people because, they claim they want to own the process. So I have found in my experience, the IT people almost never want to own the OT process. Many times it's the executive people pushing and trying to force the IT people to learn additional protocols, to kind of figure out what all of this looks like on the plant floor. And a lot of that pushback is because they don't want to do it, because they're probably well oversaturated with the amount of work they have, with Sam calling up and saying, hey, my computer's not working, and them saying, have you turned it on and off again? Right. So there are a lot of those people. And in my experience, the IT people don't necessarily want to own the process, that they want to find a good partner kind of in this journey in order to be able to go through and figure out what that looks like. And so kind of my best suggestion for that is find people on the IT side. A lot of time in larger, like Fortune 50, Fortune 500s that I've worked with, similar to Tom's example, they'll have SAP. And so a lot of times I've found people on the MII side, on the MII team, are kind of the best people that I want to work with, because they understand that OT, they understand that industrial data, and they have those connections within their organization in order to go through and make things make things work. I would also say that in this example, Sam, so we built this system on inductive automation's ignition, and so it's much more flexible. It's quite literally a platform, right? So I build a lot of things on platforms, and all of my IT people can go ahead and cringe because he said the platform word. Generally I don't like to say platform, but it is a platform, and you can build anything and everything that you want. For many facilities, looking back now, I realized that we built things that we should have bought, right? So it's kind of always the build versus buy. You can build anything and everything on this platform. Sometimes it makes sense to build. So like we built all of the HMI screens, we built the MES, we built the SCADA, all within this same platform. And then we built, bolt on, we built what could have been, bolt on maintenance and training and other things within this, maybe because we could, right? And so you can go ahead and build a lot of that within the correct platforms. If you're using something, if you're using another software solution, then it becomes, what is the best solutions that work specifically for my system? And as I talked about in the beginning, it's kind of figuring out where they want to go. If you can figure out where the end user wants to go within their process, you can help kind of say, hey, maybe an SAP or maybe some other ERP is where we want to go down the line. Let's figure out, and let's kind of go step by step back to where we are now, of we have nothing networked in 50-year-old PLCs, and figure out what software and hardwares we can pick that is going to help, make us future proof in that industry 4.0 process.
Okay, amazing. Thank you so much, Dave, for that. So Jennifer, I have best for the last. Okay. So obviously you are going to provide a lot of insights from the industry 4.0 perspective, the kind of, customers you are working with. So, tell us the architecture that you have seen in your experience.
Yeah, well, our work is about collecting information as digital 3D data. And I suspect that lots of people are working today with document-based information. Tom, you mentioned how you've got torque values, set up in 3D work, or set up in work instructions that are in 2D PDF documents that are being accessed through the system. Well, as an example for that, when we build assemblies using 3D CAD data, that typically on a drawing looks like a note, torque these bolts per X spec, right? What we're doing is actually putting that into attribute information that lives with the 3D geometry and is connecting to the actual bolt and the geometry, so that it builds you a bill of characteristics that automatically sends into your shop floor systems, so that you're not entering and re-entering data from drawing-based information systems. You're actually getting a full digital thread from the engineering data through to the shop floor. So that's really important. And I think one of the architecture pieces that's kind of been missed from the conversation we have today is how CAD and PLM systems integrate with MES, ERPs, quality management systems. They're all interconnected. And when we start pulling in the threads of 3D data aspects from engineering into the fabrication and inspection phases of the life cycle, then we're starting to connect this data digitally. And it can sort of simplify. Well, my hope is that it will simplify the complexity of kind of what we're discussing today, because it's extremely complex, the systems that are out there today. And some of it's because they've kind of been cobbled together over hundreds of years, really, right? And those systems and those processes, and we're just sort of stapling them all together in kind of a crazy Frankenstein on the shop floor. So when we talk about Industry 4.0 initiatives and that big visionary concept of digital data throughout the enterprise, it means many things to many, many different people. But from our perspective, what we're looking at is that when the consumers of the information, whether it's a welder, whether it's the guy with the torque wrench, whether it's a CNC programmer, whether it is a coordinate measurement machine programmer, whether it's scanning with X-ray technologies, the product for inspection, we are trying to look at how they are consuming the data today, so that we understand how to better author it in 3D digital data. So that's what we see. And when we go, we just did a shop floor set of interviews with basically assembly folks, where they are putting together most of our work is in aerospace and defense. And so they're putting, so I can't tell you everything, else I'd have to kill you all. But so we're working in assembly of airplanes, engines, spacecraft, that kind of thing. We also work with the Department of Energy. So we're working with highly critical components that really need a very good set of instructions. And then the quality checks that are happening in there, if we can make those quality checks more connected to the products that they're actually seeing, that's where the 3D work instructions come into play. And we're establishing not only better connectivity for the humans who actually have to do like all the quality work and actually have to put it all together. We're seeing huge benefits in navigation of 3D models on the shop floor, but we're also tightening up the design to quality loop, and that's it's a really big process step. And there's about 20 different manual handoffs during from an engineering product to the quality product, and it's huge, and there's lots of room for error. So when we put things into 3D digital data, we start to eliminate a lot of those gaps across the way. So.
Okay, so amazing, story and amazing insights about the 3D model. But for the purposes of the today's conversation, we are really on the shop floor. So design is great. I don't know if there is going to be any sort of collaboration during the design process with the shop floor. Sure, if you're producing any.
It should be.
So I don't know, Amisi, you want to talk about the actual shop floor interaction, that you experience in your stories?
Yeah, well. Yeah, I mean, it's really important to understand that what you've got today is a drawing, and that drawing, that information, even though it's given to you on a static 2D PDF, it all was authored in engineering data. But what we can do tomorrow is we can take that engineering data and you can actually utilize it more directly on the shop floor. So it's a direct consumption of the engineering data. And it's also something that they can take that engineering data. We've got people that, especially at suppliers, who take the model and then they basically deconstruct that model and build the in-process machine steps of how that model is built. So there's the geometry, has in-process steps all developed in 3D, and then that goes into the CNC machine to program the CNC operations. So that's the direct consumption of engineering data in 3D. What happens today on the shop floor is they're basically taking the drawing and they're recreating 3D plans within the CNC tools that they have. And so that's something that we can start eliminating some of the manual data reentry gaps in that process.
Okay, Mark, did you have a comment? You unmuted yourself, so want to make sure that, did you have a comment or?
Oh, no, just in general. I mean, the first law of manufacturing, right, is all benefits, in a manufacturing company are directly related to the speed of flow of materials and information. So this is fascinating, quite honestly, because from everybody's comments, really, what we're talking about is facilitating just that. And what Jennifer's talking about is getting that information to the folks who are making the decisions on the shop floor to enable them to take the right actions to enable the acceleration of the flow of materials through production. And there's just all sorts of benefits to that.
Yeah, because what we're doing today, Mark, is that we have a communication method, and it's primarily the drawing, or it's a set of documents that instruct the assembler technicians and the machine operators how to create the product. And so we kind of think of ourselves as communication specialists, and not so much as engineers, because we are trying to increase the clarity in the communication that we're driving. And then, oh, by the way, if we can get the machine tools to digitally consume directly information, then there's a huge benefit there. So yeah, thanks for that's a good rule of thumb.
Absolutely. My other comment, if I may, was a little bit of what Dave, what I've seen over the years, and I've been selling ERP and manufacturing software for an awful long time, is especially in the 90s, there was this big push for, an end-to-end ERP system, right? Wanted everything in there. Well, now everything is just so huge, from a CRM and the back end, data acquisition and everything in between. It's like, really, I think what people and even the suppliers are realizing more than anyone is you can't do everything, right? You can't do everything well. So, and I think with the integration capabilities, I mean, we're talking about all these integration points. I think with REST APIs and just the other technology that's coming out, people are less afraid, really, of integrating two pieces of data, maybe even in different database technologies, and getting those to talk. And we've seen that quite often, where we're taking information from Most ERPs have a SQL backend, but we're even, you guys probably have similar stories tied into ERP systems that are, aren't even SQL, and just able to pull that out. On not all of the ERPs, but we're seeing some of the ERPs are even supporting the capabilities where a change in the source data, like a change on a due date on a sales order or a production order, can be triggered and directly flow over to an MES or production system in real time and see that adjustment in priority. And that just wasn't the case. That type of thing couldn't happen even 15 years ago. So.
Okay, amazing. Thank you so much, Mark. So we can probably do one more quick round, based on the time we have. So one of the key component of the architecture that nobody spoke about is probably going to be, data lake. And I don't know, Tom, whether you had a real data lake. And if I talk to my friends at Splunk, they are always going to say you have to have the data lake. As part of your enterprise architecture, because that's how you are going to get, insight from all of the systems, and that's going to be your cumulative insight. And you don't want to keep too much data inside your ERP system, because that's your operation system. It's going to slow the system down. And if you are going to be changing your ERP system, obviously you are not going to have as much data. From the medical device perspective, obviously you need to have 5-7 years of history that you need to keep for your system. Now, if you look at the Industry 4.0 community, they are arguing about very different things, and that is going to be real-time connectivity between the systems. So now we have things like MQTT, OPC, UA, protocol that they are talking about, that every single edge device that you are going to have in your architecture needs to be connected in real time, and they should be receiving instructions from your ERP. So the entire process needs to be connected with your robots, with your vision systems that you are going to have on the shop floor, with your ASRS system and the in the WMS. So I don't know, Tom, what do you feel comfortable with the Industry 4.0 maturity of the company that you work with? Would you have any sort of opinion in terms of how you can advance the capabilities overall from the Industry 4.0 perspective?
So I'm not quite sure how to answer that long question, Sam.
Any quick commentary?
From a operational reporting point of view and data point of view, we are committed to direct reporting out of the ERP and MES systems. Most of the interfaces between ERP and MES in our company are real time. The production order data, the material consumption data, material master or product master updates. There are some things maintained only in MES, so there's no need for any interaction or integration, like routings. They're only in MES now. It used to be in ERP, but we've left that behind. I think we do subscribe to much more of a real-time process. Again, we didn't talk about the electronic boards at different workstations and how that is a real-time monitoring process throughout the manufacturing shop floor. But all of that is drawing upon either ERP data or MES data directly and in real time. So if I missed your point, please let me know. But that was what I thought you were asking about.
Yeah, I think we are good. So I am going to have the short commentary from everybody in terms of the Industry 4.0 maturity. I'm going to simply build on what we discussed so far, I and Tom. So when we talk about the real-time connectivity, we are talking about real-time connectivity with the devices. Meaning when I have the robot on the shop floor, that robot is supposed to be receiving the instructions, performing the action, and then sending some information back to me, because it relies on the instructions. So Mark, I don't know if you're going to have any sort of commentary with the businesses that you work with. How is their Industry 4.0 maturity in your experience?
Yeah, absolutely. And to your point directly, the way, as I mentioned, a due date as a priority doesn't work for most high mix manufacturers. So we we use a different priority mechanism. Part of that priority mechanism is the amount of work that's been reported complete. So the faster we can get that information, if we can get it directly from the machine, then your priorities are up to date in truly real time in terms of what needs to be worked on next.
Okay, amazing. Thank you so much, Mark. Dave, what are going to be your thoughts overall, the businesses that you work with? Do you feel that they were compliant and advanced overall in terms of the Industry 4.0 maturity?
I think they're still a little ways away, the companies that I've worked with, Sam. I mean, from the connectivity on the, industry side, the 4.0 industry side, I think that connectivity is happening in real time. But as it relates back to feeding that data into your ERP, I think that has still been segregated in the installations that I've seen, the examples that I've seen. And I think we're, at least with the companies that I've worked with, a ways away from seeing a real-time connection there in the size companies that I'm working with.
Okay, amazing. Thank you so much, Dave. So, Dave Griffith, obviously, I am going to ask you to rate the maturity of these guys, Industry 4.0, because you are supposed to be representing the Industry 4.0 community here. So, tell us overall from the community momentum perspective. I think there's a lot more as far as I can see. Would you agree with that? The Industry 4.0 is a lot more than what these guys are thinking in terms of the real-time connectivity of different devices, edge devices, and a lot of things can go on there.
Yeah. So first, I'd like to thank you for just setting me up for this, Sam. Right? Like, I feel like that it's just a setup, but no. So I would say that I would imagine many of the facilities that we're talking about, like most of the facilities that I am looking at, if they haven't had some major retrofit gone, perhaps like what Tom and his group have been doing, in the last 15 or 20 years, a lot of our systems are disconnected, right? And so if our systems are not connected, we can't possibly have real time. And so I think kind of the real time conversation that we're having in the Industry 4.0 community is more so, are our systems connected, right? So if our systems are connected and we have back and forth connection and we're able to pull information from all of our lines, from all of our operating stations, then they should be real. They should be real time. As to the debate as to what's real time versus not is not something we have time for, luckily for all of us in this conversation. But no, there are still many more facilities that need to have any sort of connection, right? As opposed to a report that they get at the end of a shift or the end of a day or the end of the week. I would say there is the vast majority of manufacturing in the United States, especially what I've seen, is much more we have this report, we get it at the end of the shift or the end of the week, and we don't really know what it means. And because we don't know what it means, we can't take actionable information and we cannot take action kind of in the in-between.
Okay, amazing. Thank you so much, Dave. Jennifer, I'm going to ask you, what do you feel? Do you feel that, the architecture and the companies that we have discussed so far, are they close to being Industry 4.0 compliant?
Not really.
Okay, good.
Well, and I say not really because my vision of Industry 4.0 is that we're really utilizing digital data seamlessly throughout the enterprise, and we're using it in much different ways than we're doing business today. And I think the challenge with where we are today is that people are just trying to make these little tiny tweaks, and it really is going to take a radical revolution of information architecture exchange to really get big benefits. And they're out there, but you've got to make radical changes, and you have to do business differently than you are doing it today. And I think there's real impacts that we've seen from COVID. Supply chain is a holy mess. And we can really, if we use those pain points to our advantage, to go ahead and make the changes that we've been talking about for the last 10, 15 years, then I think we can get further along and make better impacts. And then all the people on the shop floor that Dave and Tom and Mark talked about really have better lives, and their jobs are more fun, and they're having a good time. You're leveraging digital natives who grew up with digital data. So there's lots and lots and lots of opportunity. And in my mind, there's still lots of work to do.
Okay, amazing. Thank you much. So we are only going to take super short closing advice, maybe few words. So Tom, I am going to start with you. Maybe just one word or a couple of words.
I have nothing more to add, Sam. So I'll let the experts in the 4.0 world speak.
Awesome. Thank you so much, Tom. Okay, Mark, what is your closing words?
Yeah, so I think Jennifer pretty much nailed it. We've got to make the connection between what these capabilities from an IT standpoint on the shop floor to the value and the benefits on not even the top floor, but even the medium, right, or in the operations, where the heart of that manufacturing company is producing. And once that happens, once they see the connection, then I think this is going to take off.
Okay, amazing. Thank you so much, Mark. A few words, Dave Chrysler.
Sure. Understand your processes and don't recreate something that is not already working.
Love it. Thank you so much. Dave Griffith, a couple of words.
Absolutely. So I would say less is more. Dream big, figure out what you want your facility to look like, and then start small and make small, actionable, impactful initiatives to build momentum.
Awesome. Jennifer, your words.
I think that connected digital data scares people. But when you dive into your 2D static documentation methods and those processes, that should scare the hell out of you.
Okay, awesome, guys. So that's it for today. If you joined for the first time, we meet every Thursday at 5:30 p.m. for the digital transformation series. And this episode was part of that. So make sure you are not going to miss next week's show. We are going to be here with one topic related to digital transformation as well as the panel. On that note, I really want to thank everybody for your time as well as insights.
Thanks.
Thanks, Sam.
Thank you, Sam.